To reduce signal loss, when fiber optic cables are placed in the same interduct as other cables, such as copper cables, they can experience signal loss due to crosstalk. Crosstalk is the interference that occurs when signals from one cable leak into another cable. This can cause the data transmitted over the fiber optic cables to become corrupted. To protect the fiber optic cables from damage, fiber optic cables are very fragile and can be easily damaged if they are not properly protected. Placing them in their own interduct can help to protect them from damage caused by digging, trenching, or other construction activities. To make it easier to install and maintain the fiber optic cables when fiber optic cables are placed in their own interduct, it is easier to install and maintain them. This is because the interduct can be designed to provide easy access to the cables, and it can also be used to protect the cables from environmental factors such as moisture and dust. Consider the electrical properties of different cable types. Copper cables conduct electricity, and electromagnetic interference can emanate from them. Fiber optic cables, on the other hand, transmit data as light pulses through glass or plastic fibers. They are immune to electromagnetic interference. When fiber optic and copper cables are bundled together, the electromagnetic fields from the copper cables can induce currents in the fiber optic cable's metallic components, if any are present, or interfere with the optical signal, leading to signal degradation or loss. The physical protection afforded by a dedicated interduct is crucial. Fiber optic cables are more susceptible to damage from bending, crushing, or abrasion than copper cables. A separate interduct provides a dedicated pathway, minimizing the risk of physical damage during installation, maintenance, or subsequent construction activities. Sharing an interduct with other cables increases the likelihood of accidental damage, especially if the other cables are heavy or require frequent maintenance. Installation and maintenance are also simplified with separate interducts. Identifying and accessing specific fiber optic cables within a crowded interduct can be challenging and time-consuming. A dedicated interduct provides clear identification and easy access, reducing the time and effort required for installation, splicing, and troubleshooting. This is particularly important in large networks with numerous fiber optic cables. Environmental protection is another critical factor. Interducts provide a barrier against moisture, dust, and other environmental contaminants that can degrade cable performance. Fiber optic cables are particularly sensitive to moisture, which can seep into the cable and cause signal loss or corrosion. A dedicated interduct, properly sealed, provides a dry and clean environment, extending the lifespan and reliability of the fiber optic cables. Furthermore, consider future expansion and upgrades. A dedicated interduct provides a clear pathway for adding new fiber optic cables or upgrading existing ones without disrupting other services. Sharing an interduct with other cables can limit future expansion options or require costly and disruptive rearrangements. Proper planning for future needs is essential for long-term network performance and scalability. Regulatory requirements and industry best practices often dictate the separation of fiber optic cables from other cable types. These standards are designed to ensure network reliability, safety, and compliance with industry regulations. Adhering to these standards is crucial for avoiding penalties and ensuring the long-term viability of the network. Considering grounding and bonding requirements, mixing different cable types in the same interduct can complicate grounding and bonding procedures. Proper grounding and bonding are essential for preventing electrical hazards and ensuring the integrity of the network. Separating fiber optic cables into their own interduct simplifies grounding and bonding, reducing the risk of electrical problems. Also, the potential for chemical interactions is a factor. Some cable types may contain materials that can react with other cable types, causing corrosion or degradation. Separating fiber optic cables from other cable types minimizes the risk of chemical interactions and ensures the long-term integrity of the cables. The cost-benefit analysis will show that while installing separate interducts for fiber optic cables may involve a slightly higher initial cost, the long-term benefits outweigh the expense. Reduced signal loss, improved physical protection, simplified installation and maintenance, enhanced environmental protection, and compliance with industry standards all contribute to a more reliable, efficient, and cost-effective network. Ignoring these factors can lead to costly repairs, downtime, and performance issues in the long run. Therefore, placing fiber optic cables in their own interduct is a best practice that should be followed whenever possible. Firstly, signal loss reduction is a paramount reason for separating fiber optic cables into their own interduct. Crosstalk, the interference caused by signals leaking from adjacent cables, particularly copper cables carrying electrical signals, can significantly degrade the optical signal transmitted through fiber optic cables. This interference can corrupt data, leading to reduced bandwidth, increased latency, and overall poor network performance. By isolating fiber optic cables in a dedicated interduct, the risk of crosstalk is minimized, ensuring a cleaner and more reliable signal transmission. Secondly, physical protection is a crucial consideration. Fiber optic cables, while capable of transmitting vast amounts of data, are inherently fragile. They are susceptible to damage from various sources, including physical stress, bending, crushing, and abrasion. Placing fiber optic cables in a shared interduct with other cables, especially heavier or more rigid ones, increases the likelihood of damage during installation, maintenance, or even routine activities. A dedicated interduct provides a protective barrier, shielding the fiber optic cables from these potential hazards and ensuring their long-term integrity. Thirdly, ease of installation and maintenance is greatly enhanced when fiber optic cables are placed in their own interduct. Identifying, accessing, and working with fiber optic cables within a crowded and congested interduct can be a challenging and time-consuming task. A dedicated interduct provides clear identification and easy access to the cables, simplifying installation, splicing, testing, and troubleshooting procedures. This reduces labor costs, minimizes downtime, and improves overall network efficiency. Fourthly, environmental protection is a significant factor. Fiber optic cables are sensitive to environmental factors such as moisture, dust, and temperature variations. These contaminants can degrade the performance of the cables over time, leading to signal loss, increased attenuation, and premature failure. A dedicated interduct provides a sealed and controlled environment, protecting the fiber optic cables from these harmful elements and extending their lifespan. Fifthly, feature scalability and expansion are important considerations. As network demands grow, the need for additional fiber optic cables or upgraded infrastructure may arise. A dedicated interduct provides a clear and unobstructed pathway for adding new cables or replacing existing ones without disrupting other services or causing unnecessary complications. This ensures that the network can be easily scaled to meet future demands without incurring significant costs or downtime. Sixthly, compliance with industry standards and regulations often mandates the separation of fiber optic cables from other cable types. These standards are designed to ensure network safety, reliability, and performance. Failure to comply with these standards can result in penalties, fines, and legal liabilities. A dedicated interduct demonstrates a commitment to best practices and ensures compliance with all applicable regulation. Seventhly, grounding and bonding considerations play a role. Mixing different cable types in the same interduct can complicate grounding and bonding procedures, which are essential for preventing electrical hazards and ensuring the integrity of the network. Separating fiber optic cables into their own interduct simplifies grounding and bonding, reducing the risk of electrical problems and improving overall network safety. Eighthly, the prevention of chemical interactions is another important reason for separating fiber optic cables. Some cable types may contain materials that can react with other cable types, causing corrosion, degradation, or other forms of damage. Separating fiber optic cables from other cable types minimizes the risk of chemical interactions and ensures the long-term integrity of the cables. Ninthly, improved airflow and heat dissipation can be achieved with dedicated interducts. Overheating can degrade the performance of fiber optic cables and shorten their lifespan. A dedicated interduct provides better airflow and heat dissipation, preventing overheating and ensuring optimal performance. Tenthly, enhanced security is a benefit of separating fiber optic cables. A dedicated interduct provides a more secure pathway for fiber optic cables, reducing the risk of unauthorized access or tampering. This is particularly important for sensitive data transmissions or critical infrastructure applications. The benefits of placing fiber optic cables in their own interduct extend beyond just physical protection. While physical protection is a significant advantage, the reduction in signal loss due to crosstalk, the simplification of installation and maintenance, the improved environmental protection, the enhanced future scalability, the compliance with industry standards, the simplified grounding and bonding, the prevention of chemical interactions, the improved airflow and heat dissipation, and the enhanced security all contribute to a more reliable, efficient, and cost-effective network. Consider a scenario where fiber optic cables are installed alongside copper cables in a shared interduct. The electromagnetic interference generated by the copper cables can induce noise in the fiber optic cables, degrading the signal quality and reducing the data transmission rate. This can lead to network slowdowns, data errors, and frustrated users. In contrast, when the fiber optic cables are placed in a dedicated interduct, they are shielded from the electromagnetic interference, ensuring a cleaner and more reliable signal transmission. This results in a faster, more stable, and more efficient network. Another scenario involves the maintenance of fiber optic cables in a shared interduct. When a technician needs to access a specific fiber optic cable for splicing or repair, they must navigate through a maze of other cables, increasing the risk of accidentally damaging the other cables or disrupting other services. In a dedicated interduct, the technician can easily identify and access the desired cable without disturbing the other cables, minimizing downtime and reducing the risk of errors. Furthermore, consider the long-term cost implications of placing fiber optic cables in a shared interduct versus a dedicated interduct. While the initial cost of installing a shared interduct may be slightly lower, the long-term costs associated with signal loss, physical damage, increased maintenance, and potential downtime can quickly outweigh the initial savings. A dedicated interduct, while potentially more expensive upfront, offers significant long-term cost savings due to its improved performance, reliability, and ease of maintenance. In conclusion, the decision to place fiber optic cables in their own interduct is a strategic one that should be based on a careful assessment of the potential benefits and risks. While the initial cost may be a factor, the long-term advantages of reduced signal loss, improved physical protection, simplified installation and maintenance, enhanced environmental protection, future scalability, compliance with industry standards, simplified grounding and bonding, prevention of chemical interactions, improved airflow and heat dissipation, and enhanced security far outweigh the initial cost savings of using a shared interduct. Therefore, it is generally recommended to place fiber optic cables in their own dedicated interduct whenever possible to ensure a reliable, efficient, and cost-effective network. In addition, it is important to consider the type of environment in which the fiber optic cables will be installed. In harsh environments, such as those with extreme temperatures, high humidity, or exposure to corrosive chemicals, it is even more critical to place the fiber optic cables in a dedicated interduct to protect them from damage. In these environments, the interduct should also be properly sealed to prevent moisture and contaminants from entering. Furthermore, it is important to choose the right type of interduct for the specific application. There are many different types of interducts available, each with its own unique features and benefits. Some interducts are designed for underground installation, while others are designed for aerial installation. Some interducts are made of flexible materials, while others are made of rigid materials. The best type of interduct for a particular application will depend on the specific requirements of the project. Finally, it is important to ensure that the interduct is properly installed and maintained. Improper installation or maintenance can compromise the effectiveness of the interduct and increase the risk of damage to the fiber optic cables. The interduct should be installed by qualified professionals who are familiar with the proper installation techniques. The interduct should also be regularly inspected to ensure that it is in good condition. Any damage to the interduct should be repaired promptly to prevent further damage to the fiber optic cables.